All right, so jumping right into the 5.6 screencast, taking a couple of notes. So the first thing, we were talking about logarithms in class, so the first thing I want to do is write the definition of a logarithm. Okay, and the definition of a logarithm is that we have a log base b of a is equal to x, then this is the same thing as saying a is equal to b to the x power. And this is for a greater than 0 and b greater than 0. So if I just throw in a couple of examples here. So for example, if I have 100 equals 10 squared, which we know is true because 10 squared, or 10 times 10, is 100, then I could say that this is the log of 100 equals 2. Because remember, log that we don't write a base in has a base of 10. So here we would have, here's a, here's b, here's x, here's b, here's a, here's x. And we can use this property to rewrite either in exponential form, which we would have here, this is exponential, or this one would be in the logarithmic form. And we're going to use this to switch back and forth and go through a couple of examples. All right, so definition of a logarithm. Definitely pause it if you don't have this down. Make sure you have this part down. So moving on to our next screen. Let's start out with an example here where we use a log to solve an equation. So, okay, I don't know what that is. Let's try this again. Black pen, yes. There we go. Using logs to solve equations. Okay, so here's example A. And this is just solve 4 times 10 to the x power, which equals 4650. All right, so the first thing we're going to do is we're going to undo using some algebra. So undo using algebra. And what that means is really just to get rid of this 4 out front, because the 4 is just multiplication, so we can undo multiplication by dividing. So I divide both sides by 4, which gives me 10x equals, this becomes 1162.5. Okay, so now is where we're going to run into the fact that we're going to need to use the log property. Because here we have an exponential equation, and the property of logs undoes that exponential equation. So I can rewrite this using that log property. Remember, the log property says that the log b of a equals x, and that's interchangeable with b to the x power equaling a. So here I have b to the x power equaling a. So I'm going to rewrite that as log b, so b is 10, so base 10 of a, which is 1162.5, is equal to x. And see, using this property here means that this equation actually becomes solvable, because now instead of guessing and checking to figure out what this x would have to be in order to get 1162.5, I can actually plug this into my calculator, log base 10 of 1162.5, and figure out what x is. And when I use the calculator to solve that, x is approximately equal to 3.0654. All right, so we have a button on our calculator that will do log base 10. If you don't have the school calculator, all calculators automatically compute in base 10. If the base was something different, we would have to compute a little bit differently, which you'll see in the next example. So I'm going to stop this one here and screencast a different video just in case I run over time. I don't want to have to redo everything. Alright, so here's the first example. Make sure you have all this stuff down and then tune in or copy and paste the next one in.